Welcome to this comprehensive video on Rossby Waves and the Doldrums. These atmospheric phenomena play a pivotal role in shaping global weather and climate systems.
From influencing the jet streams to dictating monsoons, these systems impact not only daily weather, but also long-term climate patterns across the globe.
By understanding how these forces interact, we can better prepare for their effects on everything from agriculture to extreme weather events.
In this video, we'll break down the features, characteristics, and challenges posed by these systems, with a focus on the Indian monsoon. Let's dive in.
Pause 3s. As we explore future predictions and ongoing research concerning Rossby Waves and the Doldrums, it becomes evident that these atmospheric phenomena are at the forefront of climate science. Pause 2s. Researchers around the globe are continually studying these systems to better understand their behavior and predict their impacts on our changing climate. Pause 2s. One area of intense study is the role of Rossby waves in the context of global warming. Pause 2s. Scientists are investigating how rising temperatures may alter the frequency and intensity of these waves, potentially leading to more extreme weather events. Pause 2s. Shifts in Rossby wave patterns could result in prolonged heat waves or cold spells, significantly affecting agriculture and ecosystems. Pause 2s. Similarly, the doldrums are a subject of critical research, particularly in relation to their impact on maritime activities and tropical storm formations. Pause 2s. With climate change, the behavior of the doldrums might shift, influencing the predictability and intensity of tropical cyclones. Pause 2s. Understanding these changes is vital for improving early warning systems and mitigating the risks associated with extreme weather. Pause 2s. Advances in technology, such as satellite observations and climate modeling, are providing new insights into these phenomena. Pause 2s. These tools enable scientists to simulate future scenarios and assess the potential impacts of Rossby waves and the doldrums on a warming planet. Pause 2s. By integrating data from various sources, researchers can develop more accurate predictions and inform policy decisions aimed at climate adaptation and resilience. Pause 2s. The significance of this research cannot be overstated. Pause 2s. As we face an uncertain climate future, understanding the dynamics of Rossby waves and the doldrums is crucial for safeguarding communities and ecosystems. Pause 2s. Continued investment in climate science will enhance our predictive capabilities and empower us to develop effective strategies to mitigate the impacts of these atmospheric phenomena. Pause 3s. With this forward-looking perspective, let's now Pause 3s. Before we delve deeper into the scientific principles behind Rossby waves and the doldrums, it's important to understand their historical context and discovery. Pause 2s. The concept of Rossby waves dates back to the early 20th century when Carl Gustav Rossby, a Swedish-American meteorologist, first identified these large-scale atmospheric waves. His groundbreaking work laid the foundation for modern meteorology and our understanding of atmospheric dynamics. Pause 2s. Similarly, the doldrums, also known as the Intertropical Convergence Zone, ITCZ, were first documented by early sailors who noticed the region's peculiar weather patterns. This equatorial belt, characterized by low pressure and calm winds, was notorious for trapping ships for days or even weeks, earning its name from the Old English word doldrum, meaning dull or lifeless. Pause 2s. These early observations and discoveries were critical in shaping our current knowledge of atmospheric phenomena. By studying historical records and integrating modern technology, scientists continue to unravel the complexities of these systems, providing invaluable insights into their behavior and impacts. Pause 2s. Now that we have a historical perspective, let's move on to defining Rossby waves in more detail. Pause 3s. Let's start with Rossby waves. These are large-scale undulations in the Earth's atmosphere, driven by the planet's rotation and influenced by the Coriolis effect.
Named after meteorologist Carl Gustav Rossby, they are essential to the formation and movement of jet streams, which in turn affect weather systems across continents.
Think of them as atmospheric rivers, guiding the flow of air and influencing the development of storms, cold fronts, and heat waves.
Their wavelength can span thousands of kilometers, impacting large-scale climate patterns and even affecting ocean currents. They're key drivers of climate variability.
Now, shifting focus to the doldrums, also known as the Intertropical Convergence Zone, or ITCZ. This region, located near the equator, is where trade winds from both hemispheres meet.
The doldrums are characterized by calm winds and frequent thunderstorms, making it a highly unpredictable zone for sailors and meteorologists alike.
Historically, sailors feared this region due to its reputation for trapping ships in windless waters. However, today we understand its significance in shaping tropical weather patterns.
Seasonal shifts in the doldrums, driven by solar heating, influence the monsoon systems, particularly in regions like India, Africa, and Southeast Asia.
Rossby waves are defined by their wavelength, speed, and interaction with the Earth's surface. These waves are slower near the equator and move faster as they approach the poles.
They are essential in maintaining the Earth's energy balance, as they help transport warm air toward the poles and cold air toward the equator.
Their movement also plays a role in the development of weather systems like cyclones, as they guide low-pressure areas, contributing to storm formation.
During certain seasons, Rossby waves become more prominent, especially in the winter months, when they influence phenomena like the polar vortex, which can bring extreme cold to certain regions.
The doldrums exhibit a different set of characteristics. Located near the equator, they experience little to no wind due to the convergence of trade winds.
But this calm is deceptive. Warm, moist air rises in this region, often leading to the formation of towering clouds and sudden tropical thunderstorms.
The ITCZ also shifts seasonally, following the movement of the sun, and this movement dictates the timing and intensity of monsoon seasons across various regions.
This belt of low pressure is crucial for tropical ecosystems, but it also poses risks in terms of unpredictable weather and navigation challenges.
While Rossby waves and the doldrums occur in different atmospheric layers, their effects are interconnected. Rossby waves, by guiding the jet streams, can indirectly influence the strength of the doldrums.
This interaction is crucial in shaping tropical wind patterns, which directly affect storm formation, rainfall, and drought conditions.
For example, shifts in Rossby wave patterns can cause the ITCZ to move, altering weather conditions in tropical regions, including monsoons.
The interconnection between these two systems highlights the complexity of global climate dynamics and understanding it is key to predicting extreme weather events.
The Indian monsoon is intricately tied to both Rossby waves and the doldrums. As Rossby waves guide the low-pressure system over India, the doldrums dictate the timing and moisture availability.
Disruptions in these systems can lead to delayed or erratic monsoons, which in turn can cause flooding or drought, deeply impacting agriculture and the economy.
The predictability of the monsoon season relies heavily on tracking these atmospheric forces and understanding their seasonal shifts.
Research from organizations like the Indian Meteorological Department and ISRO focuses on using satellite data to improve monsoon forecasting based on these atmospheric dynamics.
By now, you should have a better understanding of how Rossby waves and the doldrums shape global and regional weather systems.
These atmospheric phenomena are critical for everything from agriculture to climate forecasting.
Be sure to subscribe to our channel for more informative content on climate and weather topics.
And don't forget to like and share this video if you found it helpful. Thanks for watching.